Good days to everybody. Welcome back to Mr. Lee physics class. Today we'll go through the geometric optics and we will do some revision of the lens and mirror. The aim of the study today is to study and understand the reflection and refraction. Lesson objective. In this lesson, students draw the light ray diagram for mirror. State the characteristic of image formed by a mirror and draw the light ray diagram for lens. Student also state the characteristic of the image formed by the lens. Assume prior knowledge. Students should already be familiar with the phenomenon of reflection and also refraction. Ladies and gentlemen, consider this is a mirror. The characteristic of the image formed by the mirror, let's say if the object is placed at the right side, image at the left side. So if the object placed at the left side of the mirror and the image formed at the right side, so what will be the characteristic? And if the object placed at the right side and the image formed at the same side. So this means that for these two phenomena, this means that image formed at the same side with the object, and these two conditions, the image form opposite side with the object. So let's say, so this means that if the object and the image form at the same side, so the characteristic of the image form will be real. If at the opposite side, so it will be virtual image. What is the reason? Because the image is real because the image formed by obeys the reflection. Because it's a mirror, mirrors undergoes reflection. So if the image I put at the right side, for example, right side, object at the right side, means well, the image will form at the right side as well. So that means this is the phenomenon of reflection. So that means that the image form is real. In other words, if the image form obeys the law of the reflection, so it is a real image. So this situation or just for the mirror only. How about the lens? Okay, if the image form at the same side, so it will be virtual, but opposite side will be the real. Why? If the image form obeys the rules of reflection, FRAC, rule of reflection, form undergoes or obeys the rule of reflection, FRAC, so the image form will be real. So object at the right side, image form at the left side. On the other side, so that means that this obeys the rules of reflection, FRAC. Consider there is a mirror. How we draw the image, how we determine the image formed by the mirror. So first, the light is directed from the object to the mirror. After that, to get the normal light and reflected back with the same angle. We draw two lines, okay, to get the reflected line. After that, the two line reflected, the two line reflected to the observer, is continued, extended, and we can get the image. So if for the concave mirror, let's say the object is placed further longer than the C. So what will happen? How to draw? First line, second line cut through the focus, third line go through the focus and reach the mirror and reflected back. We get the image here. This is the first method to get the image. We have another method to get the image. First line, second line, third line, then we get the image. If we combine these two methods, we get that this will be the, okay, all the lines we draw to get the image, where the image, all the lines will form at a point where this is the place of the image form. The characteristic of the image form is real because the object and the image at the same side of the mirror. Is inverted, the image is inverted and image is smaller than the object, so it's diminished. If the object is placed at C, the first method to draw, and we get the image. If we use the second method, the third line we cut through direct to the C, then we get the image. If combined both, so this is the method we draw the light ray to get the image. Characteristic of the image form when the object is at C. That means that it's real, inverted, and same size. The size of the image is equal to the size of the object. Next, if the object is placed in between center of curvature and the focus, first line, second line, third line, and reflected back, we get the image. Second method, first, second, third line we cut through direct to the C and we get the image. Combination of the two methods and the image form, the characteristics are real, inverted, and magnified. Means all the image is bigger than the object. If the object is placed as F, first, second, third line, we cannot cut through the F and reach the mirror. So we just can use a second method. And we found that the image form is virtual, upright, and magnified. Means while the image is formed opposite side with the object. Next, if the object is placed the distance near less than the F focus. So first line, second line, and third line, we extend, we get the image. So image is formed at the other side. So the characteristic is virtual, upright, and magnified. Where the object, the image is formed at the opposite side of the with the object. If it's the object is at infinity, very far away. So that means that very far, this means the light ray considered will be parallel. After reflected, and we get the image. The characteristic form is real, inverted, and diminished. Next, if it's a concave mirror, first line we direct to the normal of the optics, cut through the F, and the third line we cut through the C, where the image will form at the point here. Okay, object is far away, longer than C. How about the characteristic? Virtual, upright, and diminished. Become smaller. Next, when the object is at C, same thing. We draw to the optics, cut through the C, cut through the C, cut through the F, and cut through the C. So we get the image. So we get that the characteristic virtual, upright, and diminished. When the object is placed in between F and C, the first line, second line cut through the F, cut through the C, then we get the image here. Characteristic, still virtual, upright, and diminished. When the object is F, first line, second line, third line cut through the C, then we get the image. So this one, the characteristic of the image still virtual, upright, and diminished. Next, when the object placed between F and less than F, first line, second line, and third line, then we get the image. So the characteristic of the image will be virtual, upright, and diminished. Ladies and gentlemen, we refresh back for the concave mirror. If the mirror is placed, the object is placed far away, where the object is longer than C, then the object, if we move the object slightly, okay, nearer to the mirror, move nearer and nearer, and what will happen? What is the change of the image? So we observe the change. Nearer, far away at C, in between F and C, at F, and less than F. So this will be the change of the image. So when the object is moved nearer to the image, moved nearer to the mirror, we found that the image become bigger. If further away from the mirror, the image form becomes smaller. But when the object is at F, the image is virtual and formed at the infinity. If we move nearer again, the image is formed at the other side but upright. It's virtual image. How about the, okay, if the light from infinity, this is the light waveform. Now, we look at the convex mirror. When the object moves nearer and nearer, we found that the image become bigger. When the object moves further and further away, so image becomes smaller. But we notice or not, you notice or not, the image form always in between the convex mirror and the F focal point, sorry. So now, okay, for a lens, for a convex lens, when the object is at the infinity, how we get the image? The image is formed at the F. So this will be the characteristic, real, inverted, and diminished. Next, if the object is placed longer than C. So the first line, second line, third line cut through the center of the optics and we get the image. The characteristic will be real, inverted, and diminished. Next, when the object is at C, the image form also at C. That means that it's real, inverted, and same size. How about the next one? When the object is placed in between F and C, first line, second line cut through the F, third line cut through the center of the lens. Then we get that the image characteristic will be real, inverted, and magnified. Next, when the object is placed as F, first line, second line, third line, we notice that the image, the light ray are parallel, means while the image is formed at infinity. The characteristic will be virtual, upright, and magnified. The image formed same side with the object, means while it's at the infinity. Next, when the object is near to less than F, once we draw the light ray, we found that once we extend, we get the image. The image formed behind the object, same side with the object, where it's virtual, upright, and magnified. Image form, same side with the object. If that for the concave lens, the infinity line, infinity object, far object will form at the focus. Okay, where the characteristic virtual, upright, and diminished. How about if the object is placed longer than C for the concave lens? What will happen is we get the image form in front of the lens, in front of the concave concave lens. Means what is same side with the object. When the object, the characteristic of the image is virtual, upright, and diminished. What happens when the object is put nearer, where its position is at C of the concave lens? First, second, and third. The light rays are extended. The light rays are diverged. The image form, the characteristic still virtual, upright, and diminished. Next, when the object is placed in between F and C, what happened? First line, second line, third line, we still get the image in between, image form in between the concave lens and also the object. For the next, the characteristic of the image will be virtual, upright, and diminished. When the object is placed at the focus of the concave lens, once we draw the light ray, we still get the image formed in between the object and the concave lens. If we place, the image characteristic will be virtual, upright, and diminished. If the object is moved nearer to the concave lens, we use the same method to draw the light ray diagram. We still get the image form in between the object and the concave lens. Characteristic of the image form will be virtual, upright, and diminished. Ladies and gentlemen, what will happen for the lens when the object is at infinity, very far away, the image form at the F? Once the object is placed further from C, the image is diminished. When the object moves nearer, the image becomes bigger. Again, when the object is moved nearer, the image becomes bigger. When the object is moved far away from the lens, the image becomes smaller. When the object is at F, the image will form at the infinity. When the object less than F, the image form will be virtual. How about the concave lens? When the object moves nearer, the image becomes bigger. But the image still always smaller than the object. The image always forms in between the object and the concave lens. And the image always virtual. So, ladies and gentlemen, this will be all the phenomena, the light ray for the mirror and also the lens. So now you look at this diagram. Can you predict what is the type of lens we use? So this lens, this is not a Photoshop, editing. It's real photo from the photographer. So to get this effect, we must use the concave lens. If you use the convex lens, the image will become very, very, very big. And the image form will become very big, and the lens and the lens will look like very, very fat, extremely fat. Okay, so that's all for the revision. Okay, ladies and gentlemen, let's go through the summary for the image formed by the mirror and also image formed by the lens. So we notice that the characteristic formed by the convex lens will be the virtual, upright, and diminished. And the concave mirror form the image as at the right taper. And this will be the characteristic of the image formed by the lens. Ladies and gentlemen, if we observe that the image formed by the concave convex mirror will be same as the concave lens. Convex mirror same as concave lens. So the only difference just the red color. Where for the convex mirror, the image form opposite side with the object. Where the concave lens, the image form at the same side. The rest are equal. And the image formed by the convex lens will be equal to the concave mirror. And the only difference is the virtual image for the concave mirror formed behind lens or opposite side with the object. And the convex lens, for the convex lens, the image only virtual when it is image formed in front of the lens or same side with the image formed at the same side of the object. So these are all the phenomena you need to remember. And ladies and gentlemen, please remember to memorize all the phenomena, all the characteristic of the image formed by the mirror, and also the characteristic of the image formed by the lens. So that's all for today's lesson. So thank you very much, and we continue again on next